Okay, AP Calc BC kids. This is Unit 3, Lesson 2, Properties of Definite Integrals. So for the first one, if you have an integral that goes from A to A, there's going to be no area. So that would just be 0. Okay, if you're getting the integral from A to B of f of x, okay, let me make this f prime, because we integrate rates. I'm going to make these f primes. This is much nicer. Okay. So if you're integrating, remember when you integrate a rate, you get an amount. So you go backwards in time. Well, if I'm integrating f prime, the antiderivative will be f of x bar, right? It's always upper bound minus lower bound. Okay, this is the fundamental theorem of calculus. So in the third one here, the property of this integral is if k is a constant, you can factor it out always. Constants factor out of everything. Limits, derivatives, integrals. And then we can leave the k outside, so it's k times f of b minus f of a. Notice that the order was switched. The upper and the lower bound were switched. Now, if c lies somewhere between a and b, we did this when we had the absolute value of x minus 3 from, I think it was, I don't remember, 1 to 4 or 0 to 4, but we split it up. So you can split this up. You can make this the integral from a to b of, c is between a and b. So you can make this the integral from a to c and then continue from c to b because c is between a and b. So we're traveling from a to c first and then from c to b. F prime of x dx plus f prime of x dx. Okay, I'll leave the rest up to you. So if we're integrating two different rates, you can just get both antiderivatives. So this would just be f of a plus g of a minus the quantity f of, oh, the upper bound was b. Sorry about that. So f of b plus g of b minus the quantity f of a plus g of a. Okay, if you're subtracting these, this would just be the same thing. So it's just that you would have f of b minus g of b minus the quantity f of a minus g of a. Okay, you guys know how to distribute. So now, as far as if you have rates that you're multiplying, you can't just integrate them separately and then multiply. You would have to use integration by parts. Okay, same thing. There's no property for getting the quotient. It's only for addition and subtraction. Okay, any quotient can always be written as a product, so you'd have to use integration by parts. You are expected to know basic geometric area. So here's how this works. You have a function, the integrand. So the integrand is f of x equals 4. So let's graph f of x equals 4 from 1 to 6. Make a rectangle. So when they give us this question, what they're asking us is to get the area of a rectangle with a height of 4 and a width of 6 minus 1. 4 times 6 minus 1, which is 4 times 5. You can check it by integrating. The antiderivative is 4x. Put a bar, 1 to 6. 4 times 6 minus 4 times 1 is the same as 4 times 6 minus 1, or just 24 minus 4. So you can check to see that it works. But I do expect kids to just automatically know when you see a question like this, this is just a rectangle with a height of 4 and a width of 6 minus 1. A rectangle with a height of 4 and a width of 6 minus 1. Let's look at B. So I'm going to graph x plus 2 from 1 to 3. Okay, so this starts off at 1, 3, and then the point 3,5 ends it. So let's look underneath this. Okay, this is a trapezoid. So to get a trapezoid, the formula is half height, base 1 plus base 2. The height is your delta x, which is 3 minus 1. So this is half 3 minus 1. Your base 1 is your output at 1. So this is f of 1. And then your base 2 is your output at 3. Your output at 3 is 5. That's where those come from. So anyway, so it's just half times 2, which is just 1, times the sum of 3 and 5. So it just ends up being 8. Question C, okay. This one you definitely want to know. It comes up often. This is a semicircle, the top half of a semicircle, centered at 0, 0 with a radius of 2. So that's what this is. So the formula is half pi r squared for a semicircle. The bottom half of the semicircle would just have a negative out front. So when you go to get this area, we have 1/2 pi times 2 squared. Well, 2 squared is 4. 4 divided by 2 is 2, so it's just 2 pi. You can leave it in terms of pi. Okay, so you have to imagine that each of these functions is the velocity, and we're getting the area underneath it, and the area underneath it is the displacement. Okay, because you're going backwards, so you're getting the change in position. Okay, D. Now, this one is a little bit tricky. First, you have this area. Now, there's a difference between area and the integral. Okay, this area that I just shaded in blue, you know it's half base times height, right? So it's half of 2 times 3, which is just 3. But the integral from -4 to -1, the integral is not the same as the area. The area is 3, the integral is -3 because it's below the x-axis. So now I'm going to continue by going from -1 to 2. That is above the x-axis, so the integral is the same as the area. So we have a base of 3, a height of 3. So 3 times 3 divided by 2. So that is 4.5. Just a regular 4.5. Then we have this area versus integral here. So you have half of 2 times 1, which is just 1. So the area is 1. But the integral is -1 because it's below the curve and you're traveling from left to right. So when it's below the curve and you're traveling from left to right, it's negative. Now, if you were going backwards, everything would reverse. So I'm just giving you a heads up. If we were going backwards, if this were the problem, from 4 to -4, we would have to negate the entire problem. This would just be the opposite of whatever our entire answer is. From -4 to 4. So you do need to know that property, that those are opposites, okay? So anyway, so I get -4 plus 4.5, so I end up with a final answer of 0.5 here. So that means that this would be -0.5. And that makes sense because we'd be going backwards, so the green would be positive. That would be +1. And then the 4.5 would be negative, because when you're going backwards and you're above the axis, x-axis, then that would be treated as a negative integral. And then the blue 3 would become a +3 if you were going backwards. Okay, so we're looking at the properties of integrals. Okay, they're feeding us information. They're telling us that the integral from 0 to 3 of f of x, 0 to 9 of f of x, and then 3 to 7 of f of x, okay? So we don't have to go in any particular order here, but the integral from 0 to 7 would be the integral of 0 to 3 plus the integral 3 to 7. 0 to 3 plus 3 to 7, f of x dx. So that would be 4 plus -1, which is 3. Okay, 5 to 5 is just 0, because they're the same. Now, 3 to 9, oh, that's question E. Let me do question B next. 3 to 7, so I only want to go from 3 to 7, but times 2. So this would be just 2 times the integral from 3 to 7. So it would just be 2 times -1, or -2. If we switch the bounds of integration around, then we just change the sign. So this is the opposite of the integral from 3 to 7 of f of x dx, which is -1, which is just 1. Now, if we're going from 3 to 9, I have 0 to 9. I would do 0 to 9 and subtract 0 to 3. Because I don't want 0 to 3. I only want 3 to 9. So if I go all the way from 0 to 9 and subtract 0 to 3, I would be getting rid of the 0 to 3, and I would end up with 3 to 9. Okay? So you do have to sometimes apply logic. So what do we end up with? 2 minus 4, or -2. Okay, so it means the particle went left 2, if you think of it that way. If you just remember we're integrating velocity, it helps. So I want to go from 7 to 9. So if I'm going from 7 to 9, right, that means I don't want to go anywhere from 0 to 7. So remember I got 0 to 7 up here. So I'm going to go do 0 to 9. This thing just went to the last page for some reason. So I'm going to do 0 to 9 minus 0 to 7, because I'm getting rid of the 0 to 7 out of the 0 to 9, because I just want to be going from 7 to 9. Okay, so 0 to 9, that's 2, minus 0 to 7 was 3. So that's -1. Okay, let me scroll down to the next question. Oh, it put it away. Don't know another page. Okay. All right. So if a function is even, so an even function, easy one is just absolute value. So if you're doing an even function, so if I'm going from negative A to positive A, it's going to cancel out to 0. Now, an odd function, I meant it was going to double. Sorry about that. So this is going to be whatever the area is. This is twice the amount from 0 to A. Make sure that looks like an A. If I'm going from the opposite of a to a, if I have an odd function, okay, like y equals x is an odd function, that's where the areas cancel, the integral cancels out. Because even though the areas are the same, one is below the axis and one is above the axis. So that's 0. So now they're telling us this function is even, and they're giving us the information from 0 to 5. So from -5 to 5 would be double that. Then they're saying, okay, you're going from -5 to 0, so that would be the same, those match. Then they're saying multiply by 4, so question A times 4. Now if it's odd, -5 to 5 is going to cancel. -5 to 0 will be the opposite of 3, so that will be -3. And when you multiply by 4, you're just going to get 0. Okay, by the way, definition of an even function, just to remind you, is f of the opposite of a equals f of a. Odd function, f of -a equals the opposite of f of a. Okay, so let's look at these questions below here. Okay, we're dealing with the sine curve. Okay. So think about what the sine curve looks like. Right? Think about what this point is. That's pi. So if you're getting the integral from pi to 2 pi, okay, that is below the curve, right? Okay, so pi to 2 pi, if you think about this geometrically, okay, this would be -2, all right? Where am I getting this from? So sine in general, sine of x, okay, from 0 to pi. Let's just look at that. So this here is negative cosine, x is the derivative, the antiderivative. 0 to pi, so negative cos pi is -1, minus cos of 0. Well, cosine of 0 is 1. Okay, so this is going from 0 to pi. So you end up getting... Okay, I realized that I left out minus a negative here. Okay, I knew something was wrong. So this comes out to be 1 plus 1, okay, which equals 2. So here, from pi to 2 pi, it's just going to be -2 because it's below the curve, right? 0 all the way to 2 pi, these two areas, the area would be 4, but they're canceling out because the integral, remember when you're below the curve, the integral is negative. So that's 2 plus -2. Sine of x is just, so that just means go halfway between 0 and pi, so half of 2 is just 1. Okay, this 2, remember what I told you before about the rectangle? This is 2 times pi minus 0. Okay, so I drew a picture of the shift. So I just shifted the sine curve 2 to the right. Then I'm going from 2 to 2 plus pi, so the pi is just, the 2 plus pi is just pi more, so it ends up just being this piece here shifted, right? So that's just 2. Okay, don't let the u bother you, that doesn't matter. So if you're going from negative pi to pi, so sine is an odd function. So negative pi to pi would cancel out to 0. Okay, then we have sine of x over 2. Okay, so think about what that means. What would they be doing there? Sine of x over 2. So for sine of x over 2, you would need, your period would be 4 pi, so you would need double the amount of time to see that curve, right? So that means you would see half of the curve from 0 to 2 pi. When you have sine of pi over 2, that would be half of sine of x from 0 to 2 pi. So we already know that sine of x from 0 to 2 pi. So this is the best way to see it. So this is y equals sine of x over 2 from 0 to 2 pi. You only see half the curve. So that area would be 2. And then we have cosine x. I think the easiest way to see this is here's in green I have cosine x from 0 to pi. So you can already see it's going to cancel out to 0, but it's the same as sine from pi over 2 to 3 pi over 2. Okay, because you're shifting it. So they're shifts of one another. So if I take the cosine graph and I shift it pi over 2 to the right, I get the sine graph. Does that make sense to you guys? So 0 plus pi over 2, pi plus pi over 2, sine x dx is the same as 0 to pi of cosine x dx. Okay, so either way, that answer is 0. So you start with just sine. Okay, I'm going to finish up the video on this page. So we have this graph above. Okay, there's different pieces of the graph. So first, we're going from -3 to -2. So this has a height, a base and a height of both 1. So this is 1/2 base times height, so that's just 1 times 1. We're going from left to right, and we're above the curve. So this integral would be positive 1/2. Next, we're going from -2 to 0. So -2 to 0. Okay, this area is 2 times 2 times 1/2, right? So we have 1/2, 2 times 2, which is just 2. Okay, this one was 1/2. So the 2, however, as an integral would become -2 because you're below the curve traveling from left to right. Now we're going from 0 to 2. So from 0 to 2, I want this area here. Okay, but of course it's going to be a negative because I'm traveling from left to right. So I need to see that if this here, this yellow part comes from this black square minus this green quarter of a circle. So we're going to get the area, but then we're going to negate it because the integral is the negation. So it's the negation of, so I need to do the square. Square is 4. The quarter of a circle is 1/4 pi r is 2 squared. So this is the negation of 4 minus pi, which is just pi minus 4. Okay, that's the integral. So this here, this little yellow part is pi minus 4 when I'm traveling from left to right. Now if I go from 2 to 4, I don't know if you can see by symmetry that that's just the same thing. So that is also pi minus 4. If I'm going from all the way from -3 to 4, I would have to add all these up now. So I'd have a half plus -2 plus 2 times pi minus 4. So -1.5 plus 2 pi minus 8. So that's just 2 pi minus 9.5. All right, so the next one, okay, we're going from 2 to -1. So if we're going from 2 to -1, I have to be careful here. First I go to 2 to 0. So from 2 to 0 is going to be the opposite of what I got from 0 to 2. Okay, so from 2 to -1, I can go from 2 to 0 and then continue by going 0 to -1 because I'm traveling left. So from 2 to 0 will be the opposite of pi minus 4. And then from 0 to -1, I have this trapezoid. So my base 1 is 1, my base 2 is 2. So base 1 plus base 2 is 3. 3 times 1 is 3. And then divided by 2 is 1.5, but I'm traveling left, so it's -1.5. So this is -pi plus 4 minus 1.5. So that would be -pi plus 2.5. Or 2.5 minus pi. Same thing. I just realized I made a careless error here. This part here, since I'm traveling from 0 to -1, that would be a positive quantity. Because when I'm below the axis but traveling left, that becomes positive. So this would be 5.5, or 5.5 minus pi. Okay, -3 to -1. That just cancels. Do you see that those areas are equal? So that becomes 0 by symmetry. Then I have 4 to 0, so I'm going backwards. 4 to 0, didn't I have 0 to 4? Well, 0 to 4 would be the sum of these, right? Which is 2 pi minus 8. That would be 0 to 4. But since I'm going from 4 to 0, I have to negate it. So that just becomes 8 minus 2 pi. The last one, -2 all the way to 2. So I can just add previous problems for that. Okay, you guys can certainly figure that out. That concludes this video. Thank you, guys.